Hi everyone. It's Wednesday. Oh, hopefully you guys enjoyed the lesson yesterday. Here's another one today. All right, here's some of the answers that I've worked out for you for problem 2. So we were looking at oxidation number, how to find oxidation number for some of these more complicated entity. So here they are. Hopefully I'm right. If you have something else or you don't know where I got these numbers from, make sure you drop an email to me or come talk to me during my office hour. So here's problem 2. Here's all these oxidation numbers. You can pause this video and just take a snapshot of it if you're looking at this through your phone. And here it is. Hey, problem 4. Okay, finding out who got reduced and who got oxidized. Here it is. So I worked that out for you. Again, if I'm wrong, let me know. So let's take a look at today's lesson. Balancing redox reaction. Now, let me tell you one thing. Now, all of this reaction that are being done are done in an acidic condition. Okay? Now, most redox reaction are under acidic condition, because without the acidic condition, the reaction might not occur. Those of you who did their IA on something related to redox reaction, which I know there are like 6 or 7 of you, knew that your reaction has to be at a pH lower than 7. Now, the way you're going to balance this is very different from balancing regular reactions. Regular reaction, you guys are expert on. You have to be, or else how you do stoichiometry. But balancing redox reaction can be very, very difficult. Now, bear with me here. Okay, make sure you go back and rewind this video if you don't understand how to do this, and hopefully if you do, good for you. If you don't, hey, you're welcome to have a chat with me. So let's go. Here's a reaction that I want you to balance. Okay? Looking at this probably give you a headache already. Look at all those charges. What am I going to do? Never seen a reaction with all these charges before. Well, at least not asking me to balance this. Isn't this already balanced? There's 2 Fe on one Fe on one side, the other Fe on the other side. There's 1 Mn on one side, 1 Mn on the other. Oh, oxygen. There's 4 oxygen on the left and no oxygen on the right. You're probably thinking, you can't balance this, can't you? Well, this is not a normal balancing reaction. It's a redox reaction. It's a balancing of redox reaction. At the end, they will balance out. And we will take care of what those charges are all about. So let's do this. Well, first things first. First thing what you're going to do is you're going to divide this reaction into what we call half reaction. Oh, half reaction is going to be very, very important in 9.2. So today I'm going to show you how to break apart this reaction into 2 half reaction. Now to do that, simple. Okay? You keep or consistently keep these elements consistent. You know what I mean. Okay? Iron react to become iron. Okay? You won't have iron react to give you Mn2+. That makes no sense. Okay? And for the other half reaction, we have MnO4 went on to become Mn2+. Don't worry about the oxygen yet. We'll take care of the oxygen. Don't worry about that for now. But let's take a look at each half reaction. Now, let's take a look at the iron part of this half reaction. Now, there's no oxygen to worry about. Okay? There's actually no oxygen to worry about. So, in this case, what you need to do here is balance out the charge. The charge you have on the left side is +2. The charge you have for the right side is +3. Now, to balance out the charge, you're allowed to add electrons. Feel free to add electron on the left side or the right side. Just make sure the charge is balanced. So you have 2 plus and 3 plus. And you can add electrons, and electrons are negatives. This is what I'm going to do. I'm going to add electrons to the right side. Now, why did I do that? If you look at the left side, it is +2. If you look at the right side, it is +3 minus 1. Hey, isn't it +3 minus 1 plus 2? There you go. The charges are balanced. Let's put this aside. Let's take a look at the MnO4 side. Now, the problem with MnO4 is that oxygen. First, don't look at the oxygen, look at Mn. Is Mn balanced? Yes, manganese is balanced, so you don't have to worry about manganese. Oxygen, well, the rule here is this. You are allowed to add water at any time. Of course, you only add it when it makes sense. There's 4 oxygen on the left side. You want to make sure there's 4 oxygen on the right side. Water has 1 oxygen in it. So you're going to add 4 water molecules. Because by doing that, oxygen is actually balanced. But wait a minute. You added hydrogen. In total, you actually added 8 hydrogens. Hey, another rule here is this. You can always add hydrogen ions. In fact, because there's 8 hydrogen on the right side, I'm going to add 8 hydrogen ions. I'm allowed to do that. Look, things are balanced. Manganese is balanced, hydrogen is balanced, oxygen is balanced. Now, what you need to do right now is make sure the charge are balanced. Now, take a look at this. Take a look at the charge here. There is 8 pluses. Okay? You see how I wrote +8 there? Because there's 8 hydrogen ion. 8 pluses. There is 1 minuses. Or 1 minus. Okay? MnO4 is 1 minus. The sum of the charge on the left side is +7. Okay? Because 8 minus 1 is 7. Take a look at the right side. +2. Water? Nothing. 4 times nothing is nothing. So overall, +2. Now, how are you going to turn +7 and +2 and make them equal? Remember, you're only allowed to add electrons. Well, the most logical thing here is add 5 electrons to the left side. And we're going to do that. We're going to add 5 electrons to the left side. That will make sure that the charges are equal. Okay? Okay. We pretty much balance out both half reactions. We balance out the iron part and the manganese part. Now what we're going to do is put them both back together. Okay? But before we do that, we want to cancel out those electrons. Because if you look at the iron part, okay, there's one electron on the right side. We want to cancel that out with the 5 electrons on the left side. So we're going to have to do a little bit of a lowest common multiple here. Okay, between 1 and 5. Now, I'll tell you right now that the answer is going to be 5. So what you're going to do is that you're going to multiply 5 to every participant in this reaction. Because only then, when you combine the 2 reactions, 5 electrons will cross out. You want them to cross out. They don't look very nice. So let's combine this reaction. So you have 5Fe, 2 plus 5 electron plus 8H plus MnO4. Okay. All that will become Fe3 plus 5 electron plus manganese 2 plus 4 water. So basically things on the left, okay, all went on here. Things on the right all went on the right. Now let's see what can be crossed out here. Not too many things. We said that electron will cross out. We made it that way so they can cross out. Okay, you can't cross out the iron because they're actually different iron. Okay, one is +2 iron, one is +3 iron. Can't cross out H's, there's no H's on the right. Can't cross out MnO4 because there's no MnO4 on the right. And hey, guess what? We're done. This is how you balance a redox reaction. I know, it's a lot of work. Hopefully, I actually have one example for you to do today. I hope you guys get it, but that's how you balance a redox reaction. Now, this is actually very important. We're going to look at redox titration in a couple of days, and you need to know the skills. Okay. Hey, let's take a look at another example. Okay, let's do this example. So let's go. One more example, and I'll leave example 6 for you. And I'm sure you guys are good with that. So, again, first things first, you want to break this apart into 2 half reaction. So the first half, I'll choose dichromate. Okay, went on to become chromium +3. And for the blue side, I'll have chloride ion to become chlorine gas. Okay. Now we're gonna look at both of these half reactions separately by making sure the elements are balanced, the oxygen is balanced, the hydrogen is balanced, and the electrons are balanced. The charge is balanced. Sorry, the charge is balanced. So let's take a look at the red side. Oh, right off the bat, there's 2 chromium on the left, so you better make sure that there's 2 chromium on the right. Put a 2 there. Well, there's 7 oxygen on the left. You better make sure there's 7 oxygen on the right. Yeah, how do you make sure that happens? Well, you add water. Yeah, 7 water. There you go. Well, now they have 14 hydrogen on the right, so you make sure there's 14 hydrogen on the left. You see? Everything is balanced except for the charge. So let's do the charge. So there's plus 14 here. There's minus 2. So between the two, you're looking at plus 12. Here you have plus 6, because 3 times 2 is 6. And 0. I love these zeros. So you have plus 6. To balance out these charge, you are allowed to add electrons. So the only place that makes sense by adding electrons is right here on the left side, and you're going to add 6 of these electrons. Now balance out to be 6. So you're going to add 6 electrons to this equation. Oh, I should have thought this through. All right, let's take a look at the right side. Okay, chloride to chlorine gas. Hey, there's 2 chlorine to make a chloride, so make sure you put a 2 there, or else it's going to be weird. And there's no oxygen to worry about, no hydrogen to worry about, so you just go straight and look at the charge. So in this case, there's -2. 2, -1, so that's -2. Went on to become 0. Okay. Hey, that's pretty simple. Add 2 electrons here. Now they're both -2. Again, add 2 electrons. Okay. Now what do we do? Well, now we can combine them. But before I combine them, I want to make sure that those electrons gets canceled out. We're going to make sure that happens. To make sure that happens, 2 and 6. Lowest common multiple. That's 6. To turn 2 to 6, you times 3. So you multiply by 3. Oh, my goodness. That's not good. Multiply by 3. So that's I'm going to make sure that this is 6. All right? There you go. Yeah, why did I do that? Confuse people here. I should write this in blue. There you go. Okay. And this shouldn't be here. Should be over here. Okay. All right. So now we can combine this now. Let's combine it. So we have 6 electron plus 14H plus dichromate plus 6 chloride, that will give you 2 chromium plus 7 water plus 3 chlorine gas and 6 electron. There we go. Now let's take a look at what can cancel. Let's take we know that 6 electrons will cancel. We set it that way. It doesn't look like anything else can be canceled. Okay, so here it is. That's how you balance problem 5. All right. So problem 6. Now I'm going to leave this to you. I think you guys are capable of doing this one. I will take it up the next day and we'll call it for the day. All right.